Hey, we got it. Okay. So what's the big deal today? Pretty much the same big deal we had before. Understanding acids in the environment and your body everywhere, very helpful and very informative. However, pretty much all the acids in the environment, all the acids in your body and industry, they're all weak acids. You don't see strong acids hardly anywhere, except in your stomach. What's the strong acid in your stomach? Acid, HCl. Other than that, everything's a weak acid. So we need to know how to work with weak acid solutions. So let's see if we can first recognize the differences. We have a strong acid. What were those strong acids? Vanessa, that periodic table gave us 3 of them. Hydrochloric, hydrobromic, and hydroiodic. Yeah, there's half. And what were the other 3? Oh, and you guys know the names. Sulfuric. Nitric had what formula? Nitric was NO3. That's the dangerous one because it doesn't burn right away. And the last one, strongest, perchloric. Whoop. O4. How do we recognize these weak acid solutions, Shelby? All right. The reason why we want to be able to recognize is HCl, strong acid, in your stomach. Let's say it's 0.28 molar. I don't know what the heck it is, but it's 0.28 molar. How do you get the pH of a strong acid solution? The same thing. So you take the negative log of, if it's 0.28 molar HCl, take the negative log of 0.28 molar, right? Whatever because if it's a strong acid, it dissociate 100%. Weak acid won't do that. So that's why I'm asking Shelby, how do you identify a weak acid? Exactly. It's not on the list. Right? Not on the list. Okay. So then, height to get the pH of weak acid solutions. Because it's an equilibrium problem. That's the only way we know how to deal with equilibrium problems. Okay. Bobby, I am calling any weak acid HA. And I just want to write a general reaction for this HA. I want to write how it dissociates. It's called the dissociation reaction. It's also called reaction where you always get H plus and its conjugate base. So Bobby, if I'm starting out with HA, how would I write this acid ionization reaction for this weak acid HA? HA goes to, an H, and the A should have a minus. Exactly, right? So in general, that's how you're going to write these acid ionization reactions. You always start out with the weak acid, and it gives H plus and its conjugate base, A minus. But we're going to need, Adrian, this Ka expression to get our answers. So in general, how are we going to write these equilibrium constant expressions? It'd be what over what? According to that reaction. Which would be what on top? Hydrogen ion and A minus. And everybody on the bottom? Ha. Yeah. Do we include Ha? HA? Do we include it? Only if it's aqueous, right? But we are, right? You just leave out what and what in equilibrium constant expressions. Solids and liquids. So, heck, it's not solid liquid, so you have to have it. Okay. Here's a table of a whole bunch of weak acids, and they're... Destiny, what do you think the little A stands for in Ka? I think you're right, acid. That'd be my guess too, but I'm not so sure, but I think you're right. So there's a whole bunch of Ka weak acids, their formulas and their name. What do you think, Jessica? Rojas. The larger, the smaller, or no effect, these Kas, then the stronger the acid. The larger. Why? Because all equilibrium constants are what over what? Products over reactants. And look what the product is. H plus. So the more product you have, the stronger the acid. Okay? So the bigger those Kas are, the stronger the acid. So looking at the strongest, Alexa, in this table, which Ka is the biggest? It'd be the largest strong acid. Which one would you say is the biggest Ka in there, Alexa? So we're going to find the Ka that's the biggest number in there. Anyone, what do you see? Several people are saying oxalic, so let's just put a mark by it. So what they're saying is that you can't find a number bigger than that. Can you find a number bigger than that? Times 10 negative 2, but that's not bigger than 5 points. All right? That's the biggest one in there. So that's not a strong acid, but it's the strongest of the weak acids in the table. Okay. How about the weakest? Jessica Vaughn. The weakest one in there. Someone's talking about this. Do you have a number? Can you see a number smaller than 4.8 times 10 negative 13? What's its number? 1.2 times 10 negative 13. Oh, yeah, but 1.2. That it was smaller, isn't it? Oh my goodness. You are right. There's our smallest one. Well, it's smaller than 4.8. Yeah, I was looking at that wrong. Okay, good. There's our weakest one. So let's write action for the weakest acid listed. And Jessica pointed me out, right? HS minus. So Mariella, how would you write the dissociation reaction, or they call it the acid ionization reaction, for the weak acid HS minus? How would you write that reaction? Remember, it's always going to be the weak acid going to H plus and its conjugate base. HS minus going to H plus and S with a negative 2. Right? You take away an H, add a negative 1 to the charge, you've got it. Okay? And we're supposed to write the Ka expression also. Fine. That would be what on top, everybody? H plus and what do you call S negative 2? Sulfide, and then hydrogen sulfide. Okay. Okay. So now we can kind of get into the whole meat of this discussion. We want to get all the equilibrium concentrations of a weak acid solution. And they have to give us the Ka and the initial concentration. It's pretty much the name of the game. And in this case, we're messing with formic acid. It's used to make ethyl formate and artificial rum sweeteners, but I guess. What's the pH of 0.1 molar solution of formic acid? Now, Victoria, why can't we just take... Because pH is negative log of H, right? Why can't we just take negative log of 0.1, Victoria, and be done? Because it's not a strong acid. It's not a strong acid. So we have to go through and do a full ice, right? The quadratic mess. Okay. That means we need a reaction. Mallory, what reaction do we write that we can do ice on? What reaction would you write? HCHO2, good, goes to the CHO with a negative 1. Then everybody, plus H plus, good. Okay, you have to do ice on this. Okay, so what are we going to put in our ice table? Initial row, Javier, what are you going to put? 0.1 where? The HCHO2. Does everybody agree? Is that the initial concentration of the HCHO2? Oh, where does this come in? That comes in after we fill out the whole ice table. We set products over reactants equal to the 1.7 to 10 negative 4. That's where that comes in. Yeah, we've done this before. What do you put on for the reactant? I'm sorry, the product, the initial concentration. Dashes. They didn't say anything. And then for reactants, we always put what, Pablo, for stoichiometric coefficients and indexes. So stoichiometric coefficient is a 1. So we put a negative X or positive X? Negative X. Yeah, these are positive. And then how do we get all of our answers, Eddie, in that equilibrium row? How do you fill out the equilibrium row? 0.1 minus X. Then X and X. Okay. Is everybody reading this table right? Matteo, what is the equilibrium concentration of H plus? According to that table, it is what? It's X, right? What is the equilibrium concentration of CHO2 minus, however you call that? It's, everybody, it's X. What's the equilibrium concentration of formic acid? 0.1 minus X. Those are all of our answers, right? Okay, now I don't think we need to know all of that. We just want to know what pH is. So we just need to know what the concentration of. We just need to know, what is the pH? So we just need to know what the concentration of what is to get pH. H plus. That means all we need to get is, H plus. And in our table, now all we're after is X. Right? Just get that X. Take the negative log of it, we're done. Everybody on the same page? So that's what we got to do. Sylvia, there's got to be a way to do it. How are we going to get the X? Yeah. Ka, you have to use it. Ka is going to be what over what you're going to write? Product over reactant. So what would you write? Concentration of H plus, CH2 negative, good. Okay. She didn't skip any steps there. That should help you out. Ray, gotta plug some stuff in there. Yeah, plug in. Keep going. Yeah. Yeah. And the whole thing equals what? 1.7 to 10 negative 4, exactly. Okay. So what would you like to do first, Ray, to solve for our x? Yeah, the crisscross thing. I agree with them. So 1 point. Let's see here. All right, you're talking about this thing, all right? So multiply through the 1.74. Well, let's just write it out so no one's confused here. All right? Times the 0.1 minus x. That whole thing has to be x squared. So 1.7 times 10 negative 4 times a 0.1 is 1.7 times 10 negative 5. And then minus x, so multiply it by that. That'd be a negative 1.74 to 10 negative x. That whole thing equals x squared. So let's ask Genevieve. Genevieve, do you like positive x squared or negative x squared? I mean, that little a likes positive. She's with me. So I want to write 0 on this side, right, and bring everything over. So I would end up with what would be my next term then? Lewis, what would be my next term then? Yeah, exactly. And then it's going to be, but my c is going to be negative, right? It's negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b, so it's going to be a negative 1.7 times 10 to the negative 4. Plus or minus the square root b squared, 1.7 times 10 negative 4. Got to square it though. Minus 4 times a times c. Oh, and it's negative though. Right, c is negative. Now notice inside the square root you've got a negative 4 and then my c is negative, so that negative sign kind of disappears on you. I'll end up with okay. About 8.25 to 10 negative 3. That's what I got inside my square root thing. Okay. And if you take a look at it, you can kind of disregard minus 8.25 to 10 negative 3 because my first term is negative. It can't have a negative x. So the answer's got to be when I add a positive 8.25 to 10 negative 3. Does that make sense? You divide it by 2. Final, what I got for my x, let's put it in another color here. What I got for my x, 4.04 times 10 to the negative 3. Hopefully someone else. All right, I'll go through all that again. Okay, x. 3 of us got it. 4.04 to 10 to the negative 3. Now I got to go back and see just what the heck they wanted in the first place. They wanted pH. So if they want pH, we have to do what? Plug it in. pH is a negative log of h. And we know our h is just x. log of it, about 2.39 is what I got for the pH. Okay. Very different answer than if you would have just log of 0.1. All right, so that's very different. Okay. 2.39. So let's take a look at another one of these. But there's going to be a change. And let's just work it through regular, and then I'll show you what the change is when we get there. So Amanda, we want to know the pH of 0.38 molar HCN, and they give us the Ka for HCN. So how would you start here? Exactly. Since it's not a strong acid, we have to do ice. So that means we need the reaction. And what reaction are we going to write? Vanessa, what reaction are we going to write? HCN goes to H plus and perfect, CN minus. Okay, we got to fill it in, shall we? What are you going to put in the initial row? 0.38 dash. And changes is always minus x and plus x, and all of our stoichiometric coefficients are 1. Then we'll end up with 0.38 minus x. Okay. So we write our Ka expression now. My Ka was 4.9 times 10 to the negative 10. So, Bobby, that's going to be what over what? If you just jump right to the x's, putting it in, it would be x times x, which is really just x squared, all over 0.38 minus x. Okay. Now, I want to point out the change here. And this is going to be a nice thing. Wouldn't it be nice? Let's make this in green, because it would be a nice thing to do if this could happen. If you could write this, 4.9 times 10 to the negative 10, and write an approximate or something. We're going to change it a little bit. It's just x 0.38. Wouldn't that be nice? Because how would you solve that? Multiply both sides by 0.38, then take the square root, and you're done. No quadratic formula, right? Just being able to drop these little minus x's, right? You can't help, right? You can do it, but let's put it in a color that's important here. Only because of that. You can drop the x. Why? 10 to the negative 10. That is a really big equilibrium constant, or it's a really small equilibrium constant? It's extremely small. That means I'm going to have a lot of product or a little bit of product. A very small amount. Well, if I have a very small amount, that means x has to be extremely what? Small. X is really small. Well, I'm taking 0.38 minus x. 10 to the negative 10. Man, that's a decimal point with 9 zeros and a 1. So I take 0.38 minus something that's on the order of that small. I'm going to get 0.379999. There's no difference. So you can do that. You can drop these x's, right? So let's go ahead and finish this then. We're going to get 4.9 times 10 to the negative 10 times 0.38 I got about 1.3. Oh, that's my final answer. 1.36 times 10 negative final answer for my x. And they want to know what pH is. Oh, I took the square root right away, sorry, on my calculator. So take 4.9 to 10 negative 10 times 0.38, hit equals, then take the square root, and you'll get this number. And they want pH, so I just do what to get my answer? The negative log of it. About 4.87 or so. Okay, 4.87. So Jessica, Rojas, isn't that a nice thing to do? When can we do it, though? When you have 10 to the negative 10. How about 10 to the negative 9? Can. There has to be, pretty much you have to do a bunch of these questions. And then you start finding out when it starts making a difference. And it starts making a difference around 10 to the negative 5. If it's if your Ka is 10 to the negative 5, you are on the borderline. Right? If you're feeling lucky, go ahead. But otherwise, you should go through the whole thing. Okay? So let's be negative. This is you're writing the quiz. You're writing the exam. Alexa, which weak acid would you definitely not want to see on this quiz or the problem? You can't drop the X's. Which one would you not want to see? Yeah, but what's an example of one? Oh, I see it right at the very top. Yeah, here's one. That's questionable. But you might be able to get by with it. What's one that's not questionable? HSO4 negative, right in the middle somewhere, you're saying. This guy? Oh, yeah, horrible. That's definitely too big. All right? So anything 10 to negative 5, questionable. But definitely not 10 to negative 4, negative 3, negative 2. You have to do the full problem. You can't drop any X's. Okay? So far there's been two types of questions. One is where we're going to do ice, but we can't drop any X's because our Ka was 10 to the negative 4. The type of question is, oh, we can drop our X because now our Ka is 10 to the negative 10. Okay? Here's a third type of question that I think you're going to see. They want to know what the Ka is for a weak acid, and just in general, HA. They tell us the pH, and the concentration is 0.52 molar. So see how they give us the concentration. Doesn't that look similar to this? They give us the concentration. But they wanted to know what the pH was. See, find the pH. Here, they gave us the pH. So didn't they? They kind of told us the answer. Right? Because do you remember when you get, what is this pH deal? It's right here. Right? It was the negative log of our hydrogen ion concentration, which is our X. If they give you a pH, how do you get hydrogen ion concentration? What's the relationship for it? pH is a negative log of H. Someone said it. How do you get the H? Use the 10. It's going to be 10 to the negative 2.8, or in general, 10 to the negative pH, right? So we can get our hydrogen ion concentration. Why is this a big deal? I don't know what K. Well, we're just going to do our ice table, fill it all out as much as we can, with all the x's and stuff. Write the Ka expression with all the x's, and then just, if you don't see it, let's just go ahead and write it out. What is our reaction? And we have to do ice on it. And then once we get it, we're going to write our Ka expression. But let's write our Mariella. What reaction are we doing ice on? HA goes to H plus and A minus. Okay. And now our initial row, Victoria, what are you going to put in there? 0.52 dashes, exactly. And negative x and x's. 0.52 minus x and x's. Right. Now we can, Mallory, the Ka expression, what would you put in there? X squared all over 0.52 minus x. That will be our Ka. Okay. So Javier, how are we going to get the x? We don't know. We don't know. We're after this Ka number. Yeah, that's how we're going to get our x. Because remember, our hydrogen ion concentration, that is our x. Right? Because look at right here. That is our x. So 10 to the negative what is going to be my hydrogen ion concentration, which is my x? 2.8. 1.58 times 10 to the negative 3. Thank you, sir. Okay. Now I don't know if you can, how you're saying to drop the x. I don't know if you can or not. And you have a calculator, so why mess with it? Just get it exact. I wouldn't drop any x's to get the Ka. 1.58 times 10 to the negative 3. Let's square it. At 0.52 minus 1.58 times 10 to the negative 3. I wouldn't drop it. If you have a calculator. Oh, I don't have one to borrow. Square divided by. I got 4.8 times 10 to the negative 6. Okay, good. 4.8 times 10 to the negative 6, the final answer. There it is. Okay. So 3 types of questions. One is where they ask for the equilibrium composition. And if the Ka is 10 to the negative 6, negative 7, negative 8, negative 9, hey, you got to do a full quadratic. But if it's 10 to the negative 4, 10 to the negative 3, even, no, 10 to the negative 5, I don't know what to say about. But 10 to the negative 4, 10 to the negative 3, 10 to the negative 2, you can drop. You can, well, it's the other way around. Oh, it's the other way around, isn't it? Because K's have to be really small, and then I don't have much product, my X is really small. So it's the other way around, right? So you want to see 10, you want to see 10 to the negative 6, 10 to the negative 7, Ka. You don't want to see 10 to the negative 2 and things. Okay. And then this is the third type right here, is where they give us the pH, and then we just calculate the Ka. So, this question. Let's see if I've totally confused Pablo. Pablo, is this a question that you're happy about or not? No, it's going to be a lot of full quadratic. Full quadratic. So see if you can work it out. We want to know the concentrations of everything at equilibrium. The conjugate acid, HF, H plus, and the conjugate base, F minus. You're going to have to do a full quadratic treatment there because our Ka is only 10 to the negative 4. See if you can work it out. I'll be glad to help you. If you're not sure where to start, just ask. Okay. B and a negative C, if that's how you got it. Okay. So the minus 1 doesn't make any sense, so I'll get a negative answer. I'm going to have to add it. 0.0195 is what I got for my x.
Yeah. I have 0.0097
So you have 6.8 times 10 negative 4, negative b. Oh, it's... Oh, and it's negative b. So what did you see where I screwed up? This should be positive, shouldn't it?
No.
Oh, huh? Yeah.
You just didn't divide it by 2.
Oh, I forgot to divide by 2. Thank you, sir. You're right. You told me that. So it should be divided by 2. Yeah, like 9, yeah, or 9.77 to 10 negative 3 or something. Yeah, I divide by 2. And then you substitute back into here. Substitute all your x's in, and then you'll have all your answers. Because they want to know what all the concentrations are. You should put big M, otherwise you have no units and you lose a point. So the H plus and the F minus are the same concentration, whatever X is. But the other one you got to subtract from 0.15. There's another one. If you got it, if you got that one, try doing this one. Same as in your notes, I just changed the order of the questions. You want to make that last one an easy one? Do that. Change it to, what was an easy one? Yeah. Let's do, yeah, let's do boric acid. 5.9 times 10 negative 10. I don't remember what the heck the formula was. H3BO3, 5.9. H3BO3. All right, who says Christmas doesn't come around?
5.9.
10 to the negative 10. All right. There. Now you can get out of here. Find the KH of 0.3 molar H3BO3, and the Ka is 5.9 times 10 to the negative 10. A lot easier question. H3BO3 goes to H2BO3 minus plus H plus.
No. H plus and H2BO3. Very good.
Yep. So that would be your reaction. Oh, yeah? Yeah, I changed the order. That screws up a lot of people.
Once I like get this right here, I just take off the X.
Yeah, drop the X, and that's all you got to do. Exactly.
And that's pretty
Yep.
much also H plus, right?
Yeah, because X is H plus. Yep.
Oh, okay, so then I just bring it over.
Yep.
And that's,
You got it. I'll be glad to help you out.
second, you push shift. You didn't push shift.